So thanks everybody for hanging out today. I know it's getting towards the end of the conference, but Brett and I are here to talk about SPDM. A couple of things that we've done lately in the last years in SPDM. First of all, the PQC support. We're working on something called authorization, and then the storage binding was released. Just a quick disclaimer, some of this stuff is a snapshot of work in progress, and so may perhaps change, perhaps profoundly. So
by the end of this session?
Depending on the feedback, perhaps. So we've got a bunch of alliance partners, for those of you aware, heck, there are probably some of you that are working on SPDM with us and driving requirements in, and we're trying to meet your needs. As always, give us feedback. We like it. There's a forum externally, SPDM forum you can click to through the SPDM page. And even, if you've got feedback that's not necessarily part of your company, you can always give us feedback there. We look at it every week to make sure we've incorporated it and discussed it at the very least, and try and give you a response in real time. Quick agenda for today. We're going to go through the SPDM background just for completeness. How many of you have never seen the background behind SPDM and why we're doing it? Okay, there's a good chunk of you. All right. Some of you probably have seen it and have just raising your hand. But, and then we'll go into updates we did with SPDM 1.4, the binding to storage that came out this year, and then something we're working on called authorization. So this picture is showing its age a little bit at this point when you consider some of the expansion for the bindings of SPDM, but the attack surfaces are still very much true. There's attacks on fabrics by people that are inserting devices in the middle, snooping probes, substitution of devices, substitution of firmware, insertion of malware. It's all possible inside the box with somebody once they open the skin of that thing. Counterfeit devices, supply chain compromise. There's people that doubt whether some of that has happened, and I think some of us know that all of that has happened to one company or another at some point during the process. And that was the whole point of SPDM, is really any component is a potential attack vector. Once you turn on that machine, hopefully you've got some silicon root of trust, maybe in the BMC that's monitoring things going along. It can trust itself. How do you expand that root of trust so that by the time the OS boots, it can know it can trust everything from there forward. It can trust all the devices in the machine. So you're not being paranoid if they're out to get you, and largely they're out to get you these days. So that's really what we're trying to do, is expand the root of trust to the entire platform. So, but why SPDM specifically? Well, there were lots of ways to extend that root of trust, but proprietary isn't a good way for the ecosystem. Then you end up with the M times N problem. For every vendor, there ends up being a different way of doing it. You people that do standards for a living really understand this, so I don't need to spend a lot of time on it. But we also wanted a common mechanism for both the control plane, the management plane, and the data plane. I've learned I got to watch the word control plane with switch people, so if there are any of you in here, yes. Control is different from management. For some of us inside of a platform, they're the same thing. So, but if you've got a device that's supporting some kind of crypto or hash or whatever, having a different set of requirements for the data plane and the management plane is also a burden on that device. So we wanted one way to do it, and that's where DMTF stepped forward to come forward with the SPDM protocol. So the overall goals were really fall into two categories, right? Device attestation and authentication, and that's largely what we did in version 1.0, and then start doing secure communication over any transport. And that was what we added in version 1.1. And so that ability to, make sure that the device you're talking to is in fact what you think it is and doesn't have compromised firmware, at least as far as it can tell, is really important to the infrastructure. And then to stop those entity in the middle attacks, you need some kind of encrypted traffic in between the two. And again, that goes for the data plane as well, and you see people like CXL and PCI picking up the work there. But you need it for the management plane too. It gets a little tough if you're trying to do it on I2C, but as we slowly go through the infrastructure, replacing those antiquated pipes that are helping us manage systems, you can start putting more bytes over that management infrastructure. You really need to protect that, because the details of information and the exposure of that information can really open up yourself to attacks. The last thing we're trying to do is support the latest crypto standards, well, that proved to be a little bit interesting when it came to PQC, but we'll go over that in a second. So just a quick history of SPDM. As I said, the 1.0 spec, it was measurements, and measurements can be anything from a token to an entire firmware blob to a whole firmware manifest. So if you've got the ability to either measure it before it landed or at a live measurement, the measurement protocol supports both of those. Device attestation and authentication, is this from the manufacturer I think it is from, and can it attest to it? And so we've got a way in the spec to do that as well. And then, as I said, version 1.1 was, okay, let's do some kind of secure session, whether that's a public key exchange or a symmetric key exchange. We put that in there. And then some components in the system they're sophisticated enough where they need to know if they can trust the other end they're talking to. And so we added mutual authentication, so both ends of the wire can exchange information about each other and figure out, well, okay, that thing runs two ways. Are you really the BMC I think I'm talking to before I go talking to you? So we put all that in there. When version 1.2 came around, we're thinking, all right, we've done a pretty good job. And then we realized as people start landing this thing, we don't have a standard way to install the certificates. And so now our factories are slightly different for every component vendor out there. The factory burn-in or whatever, and the landing of certificates is slightly different. So we came up with a standard way of doing that. And we also added the alias certificates, which is a nice way of supporting TCG, which is the derived certificate. These messages were getting a little bit bigger, and some of the management traffic where we put chunking into certificates when you'd get and set a certificate. But what about the rest of traffic? And so we put in a standard chunking mechanism as the payloads were getting larger. We added some algorithms for the Pacific Rim. We added some new OIDs, and then we deprecated basic mutual auth. We originally put that in for one of the alliance partners. Once we put in a key exchange, we really didn't need it anymore. We had real mutual auth. So we deprecated it because it had some problems in a lot of open scenarios. And so rather than trying to fix those, we just deprecated and said, you know what, forget basic mutual auth. If you want mutual auth, use real mutual authentication. Version 1.3, we added eventing. It's nice to know when something happened inside of your secure infrastructure. So we leveraged it off of PLDM so that everything out there using the management infrastructure that had PLDM code wouldn't have to rewrite a whole bunch of code. We added multi-key, which was quite different. Every system up to this, you kind of assumed one private key in there. And, well, you really don't want to mix keys for use cases. So we needed multi-key support so you wouldn't be using the same key for multiple use cases. Generic certificates, the ability for anybody to kind of upload any cert they wanted, because the whole supply chain and OCP was coming in and saying, well, we want certificates for this use and that use. And so, okay, let's do generic certificates that really have nothing to do with the hardware. MEL and HEM are ways of doing hash extended measurements and measurement extension logs so that as you're making changes to the system, configuration changes, updating settings, updating firmware, and then you're going to reboot, you can dynamically watch all those changes in the system so that at next time it boots and gives you a different measurement, you know you can trust that measurement. So it was really a continuity of trust and operation through the lifetime of the system. We added endpoint info, and it turned out not everybody out there used MCTP. So, being DMTF, we have this thing called MCTP that kind of does everything. PLDM over it does firmware update or redfish packets or sensor data or the rest of it. And MCTP has a way of identifying the endpoint, or FRU data. Well, not everybody has all of those components, so we needed a generic way of saying, well, what kind of thing are you before I start this traffic? Before we start talking, what are you? So we added that. Over the years, we've added a bunch of bindings. We started out with MCTP to SPDM, which is the basic 1.0 measurements and device attestation in the SPDM protocol itself. And then, well, how do we do encrypted traffic? So we came up with a mechanism. You're actually using a different MCTP type. Once you started a secured message exchange and kicked it off, you're using an SPDM type that's MCTP type that's different. Secure messages to SPDM is part of all of that as well. It's kind of that binding spec that we needed to divide that spec in half because again, part of the industry wanted to leverage that code. They didn't want to reference our whole encryption mechanism. You know, PCI uses a different way. But your general packet format's pretty good. We just want to put a different header in there. So we broke that spec apart into 2 different specs so that they could leverage one and not worry about the rest of our spec and reference the whole spec. So it's kind of one of those specmanship things where we had to have 3 different bindings just to get the spec out. And then SPDM over TCP, that's kind of why I was saying that picture needs updating. It isn't really that TLS isn't any good or MTLS isn't sufficient. But what they don't do is if you're building a rack manager, they don't let you measure, oops.
Is your power plugged in?
My power's plugged in.
Is it plugged in? How do you turn it off and on?
My laptop is still doing fine.
Who hacked it?
We've had some problems with this projector, so
It doesn't have SPDM.
turn that off.
I'm plugging it back in. That's the first thing you try, right? Unplug it and plug it back in. Reboot the projector. Anyway, I'll keep going. So there's SPDM for TCP is really meant for, I'm building a rack, right? I've got a rack manager and I'm going to talk to the BMC. How do I know I can trust that BMC? Well, you can use the certificate exchange in TLS and MTLS just fine. I want to measure its firmware workload and make sure, you know, the code that's out there, and that's the one thing you can't do with TLS, is measure the components inside the system and make sure it is what you expect it to be. And so we did SPDM over TCP. It can leave the box, it can leave the rack. If you get some creative needs for implementation, I'd love to hear them. But really, that's what it was intended for. And then SPDM over storage, Brett will talk about here in a second. As well as attestation, which is a whole different ball of wax we kind of didn't sign up to in 1.0. You know, that whole authorization. Sure, you can go over the secure protocol and do the key exchange. Anybody can do that, really. How do I know you're allowed to do what you're doing? And you know, once you're inside the BMC, all that gets kind of interesting. So SPDM 1.4, what we did was we added PQC support. That was kind of the big thing, was FIPS 203, 204, and 205, expanding SPDM to hit that target. I'll go over that in more detail in a minute and what it took to do that. Another thing we added was certificate slot management. For those of you familiar with SPDM, there's 8 slots by default, but the dirty little secret we didn't tell anybody was, well, that depends on the algorithm you negotiated. And when we put in multi-key, depending on which key you're using and which certificate's associated with it, there's only 1 bank per algorithm, so you negotiate that algorithm, you're using that bank. Well, if you supported multiple algorithms, there was no way to get to that other bank. You'd have to negotiate using that algorithm, then you could start using those certificate slots. That wasn't really a problem in 1.0 and 1.2 and even 1.3, even though we had multi-key support. It certainly was in 1.4 when you're adding truly multiple different, a traditional algorithm and a PQC algorithm. You're expected to support multiple algorithms as we go through this transition. A lot of the implementations before that were really only supporting 1 algorithm anyway, 1 algorithm per market or whatever. So you didn't really have to worry about slot management. And Brett kind of pointed out, I think it was you, it's like, hey, all of that's implicit. No, we better put this in here before, you know, because sure, I'm going to do my traditional algorithm, and then that's going to let me manage my PQC certificates. I really want to do that, sure, through a secure session or whatever, but I don't want to have to negotiate my PQC algorithm just to do that, or vice versa. So the bank commands were put in there. We added a whole bunch of stuff. If you read any of the SPDM specs, there's this wonderful section at the end that has all of the changes that were put in. But some of the more drastic ones were set key pair, reset cap. You know, do you have to reset? Added salt length requirements for RSA PSS schemes. Turns out that's important for interoperability, for everybody to use the same salt length. And there was a whole bunch of minor clarifications and fixes. And we use GitHub for everything in SPDM and largely in DMTF now. So it's a very, you put in an issue, do you do a pull, you change everything in the pull. If it's ready when the release goes, great, it makes it in. If it's not, well, we'll save it for next time. And so every one of those, every time you do a pull, you got to do your change bar at the end. And so you'll see a bunch of little minor fixes, because if they're ready, we'll pick them all up whenever the spec is ready. So specifically, We didn't wait for, originally, we thought, hey, we'll wait for TLS and MTLS and X509 to do all their updates, and once all of the industry is stable, we'll ship SPDM. Well, that was a nice thought. Silicon vendors need a little bit more lead time than software vendors do. So SPDM is actually the first PQC support protocol that's a standard. We're taking it through ISO right now. So, well, that's actually 1.3. So it's not an ISO standard, but we'll let it settle a little bit. But yeah, SPDM 1.3 is set to be a ISO standard. So what we did instead was, okay, FIPS 203 and 204 and 205, that had MLChem and MLDSA and SLHDSA, which were the standard algorithms. We also figured out, we had some clever people figuring out, okay, we don't have to wait on X509 because the OIDs really aren't going to change, and X509 doesn't need to be updated because you're just going to reference the OID in your cert anyway. So we didn't have to worry about waiting for X509, and then we did have to wait for 800.227 because it's nice to publish the algorithms out there, but what are the parameters for that algorithm that have been tested and validated? And for those of you that are familiar with all of that, you understand. But rather than wait for anybody else's usage of it, we waited for 800.227 to tell us all the valid values that we needed for any of the algorithms. There's no hybrid support. If someone can point me to we would still be waiting if we waited for hybrid support to publish SPDM. There's no standard mechanism right now. There's a bunch of people playing with different ways of doing it. I hear TLS is close to a way of dealing with hybrid, but we didn't want to wait for a hybrid cert format to be standard. I mean, an RFC takes a long time. We didn't want to wait for the TLS code and RFCs to all go through on what hybrid support is. Will we do hybrid in the future? I don't know. If you think we should, let us know. But before you bring it in, point us to the standard version of it so that we can just pick up the work and go. When it came to putting in PQC support, we had originally based SPDM on some USB work. And we figured that was pretty good. And we kind of ended up, which was kind of based on TLS to begin with. And so we largely kind of based our stuff on TLS. But one of the problems with the USB work was all of the values were, shall we say, a low overhead device optimized. So low bandwidth device optimized. So they were all small. And we took the first look, a year and a half ago, and Xiaoyu at Intel had done some calculations of what these algorithms, the sizes were. And, we were dealing with, okay, we could deal with 4K and the fact that you could have, just 4K or 64K, max and hashes at the end of it. We're like, oh man, that completely blew our size limit on the protocol. So we had to go through and change a bunch of core messages. Right, so we added and expanded fields to certs and key exchange and slot management because anything carrying that PQC data is going to naturally get big once you're using some of the larger algorithms. Then we had to change all of the key exchange for digital signature and add MLDSA and SLHDSA, so all the challenge auth measurements, endpoint info, anything that can have that kind of information in it naturally had to be made bigger too. And then for MLChem, for the secure sessions, we needed to change key exchange and key exchange response. So, and then all the supporting things that go along with all of that, like negotiate algorithms. Well, we had to add not only the PQC algorithms, but we have you can have your own OEM algorithm section in there, and we need to do a complete section for all the post-quantum ones as well. And so some of those kind of got extra fields added to them or expanded. Set cert, naturally, that's going to have to get bigger because PQC cert's going to be bigger. Set key pair info had to be expanded for not just traditional key pairs, but PQC key pairs, and both set key pair and key pair info had to be changed. So I talked about the banks earlier. What we included, and this was kind of brought up last minute, and luckily Brett largely did the heroics to get bank in there at the last minute. Again, today, not a problem. Most folks, it's just one signing algorithm, right? And a device can have up to eight slots, numbered 0 through 7, where 0 is kind of the device cert and the device signing, to store all the certificate chains associated with any given algorithm. And when you did negotiate algorithms, you'd put in all your choices. Your device would return 1, the one that got selected, which tells you right away, if you want your device selecting your algorithm, that's the way to do it. If not, do that once and then do it again, this time with the one algorithm that you want. It takes a bit, if you don't have a priori knowledge, to actually negotiate the right algorithm. But if it only supported one, that really wasn't a problem. Well, what the bank slots does is, again, it's implicitly selected via negotiated algorithms. And instead, what we did was we added a command that really is set bank, get bank, and then key pairs associated with the bank and all of that are taken care of too. So we think it's a fairly complete set of commands, and largely it's for, bank 0 could be, like it shows here, ECDSA P256 or RSA 3072 or MLDSA 87. We know you're going to have a traditional algorithm. If you're supporting PQC, you're probably going to have both, at least for a while. So we know everybody's got at least 2, if not more. So that bank and the ability to not only get the bank information, but you're not going to be able to get the private key or anything like that out of it, but you'll be able to do all of the previous commands, particularly with setting the certs, as well as assigning a key to a certificate slot. Do your signing request and the rest. Any questions so far?
So because of the change in the message formats and everything, that did break compatibility with previous versions?
We have so it depends on your version of compatibility. One of the things we did right up front was we put the version in every command right up front. So we tried to extend at the end where we could. We couldn't do it everywhere. When we're fortunate, and I probably haven't been pushing libSPDM enough. We've got a code task force implementing all of this that we hope is good enough for the industry. So rather than roll your own, please leverage SPDM, put in issues on it. There's a lot of work going into it in the industry, and we greatly appreciate the fact that our member companies are bringing people forward. When we talk to them, they really are, we're just like, okay, we can do all this, and then you start to get into the fixed length stuff and then the variable length stuff. And boy, the variable length stuff starts getting a little squirrely when you start trying to add then some fixed length stuff at the end. And they were very much like, no, just put all the fixed length stuff at the beginning. So we did change the formats a little bit. Where we could, we didn't. So it's largely compatible, but again, it's real nice to have, if you haven't seen SPDM, version and negotiate version is right up front, and then every command has its own version on it. So, we should be good.
And setting the bank is the first thing you have to do because now you have to do.
Well, that's really for your security manager to do, right? Sorry, the questions, I'm not repeating them. So setting the bank, right, is that something you have to do up front? Well, probably factory, yes, absolutely, right? Set cert and set your bank and certificate signing requests, generate CSR and all that.
1.4 is not requiring more than one bank, or just a minimum is one.
One version back or one algorithm?
One bank.
One bank, yes, absolutely. And if you only support one bank, the bank commands don't make a lot of sense, right? So if you only got one bank, you don't need to support it. In fact, I think there's capability bits in there for all of the optional commands. Do you support them or do you not? Endpoint info and bank and multi-key and all of that. So if you support more than one algorithm, they become very important though.
So from what I'm hearing, your view of the hybrid algorithms is they're still so unsettled, you don't even want to set a target. You might incorporate those in a future version is that a true statement?
So the question was, gee, the hybrid algorithms are so in flight, you don't even want to set a date. Let's see, as a standard body, we need to be able to reference some standard document, something somewhere, right, where we can truly reference it. I have tried to predict our own group when we're going to try and publish stuff, and I fail miserably at that. So I'm certainly not going to try and attempt, when anybody else out there is going to try and get any of these standard definitions out there.
And for what it's worth, NIST has said they have no plans, at least nothing they're discussing outside, to do hybrid algorithms.
And so, yes, NIST has said they have no plans, at least so far. Nobody's twisted their arm enough to do hybrid algorithms. And certainly that's the large push for doing PQC in the first place is all the CNSA requirements, right? So, however, there are other people in the industry. We certainly didn't put the Chinese algorithms in for them. So, being a standard protocol, we've got multiple markets that we need to, I can so totally see somebody wanting to do hybrid. We had people come in when we first brought in PQC saying we've got to have hybrid, and the group went, I don't have the stomach for that right now. A question, what's hybrid? So hybrid is the mixing of traditional and PQC algorithms. And there's multiple ways to do that. Do you concatenate them end to end? Do you encrypt one in the other? What are the possibilities of using them two together where you might actually, they're both strong, but together you expose a weakness? There's all those kind of considerations that I don't want to be in the front of. And so that was really, and the group felt the same way. It wasn't just me.
But is the end game there to have a single certificate and you only have to run the algorithm once?
So the question is the end game to have a single certificate? And I'm not going to try and predict that either, right? So if I select two algorithms and want to run them together and there's an encapsulation mechanism, does that mean two certs? Or is there one hybrid cert? Or you know what? I'm just not even going to pay attention to that until the ink is dry.
I've got some links in my presentation for the next hour.
Okay. Stay tuned, I guess is the answer there. Stay tuned for the next
Thank
presentations.
you. I updated my presentation so it wouldn't be lying.
So that's the reason for the questions. All right. One more question?
Yeah, so as far as having multiple slots per bank, so you're saying that you need to have up to 8 certificates per algorithm?
All right, so the question is, and this is true whether you got banks or not, there's 8 slots. Do I really need them all? And the answer is, well, really only I think 0 and 1 are required. Is even 1 required? It's just 0 that's required. So it kind of depends on your implementation. How many slots can you afford a certificate chain for? And if you're letting generic certificate chains show up, those could be pretty long. So how much storage and what's your storage like? How protected is it where you're storing the certificate chains? That's completely a vendor problem. What the command allows is for you to figure out how many slots are there, which ones have valid data, and to switch banks between algorithms if you need to.
How did you figure out you would need 8 slots?
How did we figure out we would need 8 slots? We didn't. USB had 8. So we leverage USB, and you're sitting around and you go, all right, I can figure out 0, and my company probably wants 1, and another standards body probably wants numbers 2 and 3, and so I'm used up half of them already. And do I want to do more than 8? I'll wait till someone says I need more than 8, and I don't want to put the burden. So that was my line of logic going through, and probably everybody else was similar. 8 per bank.
We started at 8 in Genetic also, and backed up when PQC came out.
And you do allow the switch from classical PQC and PQC back to classical?
So the question is, do you allow a switch from PQC back to traditional and traditional back to PQC? If the device responder supports it and the requester supports it, you can have them both going on separate channels simultaneously.
Yeah, but this is more
So
one or...
it's really one or the other per channel. You're not going to switch back and forth between them. Honest, you're going to destroy one because of the way, the way everything is set up. You're really not going to switch back and forth. Now, measurements is different. You can use them on the same. But once you go an encrypted session, you're going to use one key per session, one algorithm per session. If you want multiple ones going simultaneously, do that. Good luck. I'm not sure what the device would do about that, but I bet somebody out there is doing it. But on a single session endpoint from the transport, you're going to have to completely tear it down and then start from scratch because of the way, if you go through and look at the hash, the transcript hash, but it's
VCA.
VCA, thank you. When you go through version capabilities and algorithms, you're generating hashes all along, and you're going to have to start that hash algorithm all over again, or you're not going to get through key exchange. One last question, then we'll let Brett go.
Are you going to resubmit these with without the DMTF confidential?
Whoops. I think that's just on that slide. Yeah. Good catch. Whoops.
For now, we can't use this at all.
Well, remember, some of that said this could change perhaps profound. No. Last one is just for references. I think I've talked about most of these already. Anybody need to, you're better off just going to dmtf.org/standard/SPDM and clicking from there. So,
Well, you know, I went out to DMTF.org and started clicking on stuff. I'm working with SAS and SATA, and John Gelman here has been working closely with us. But when I tried to filter through that stuff and find out what my storage device was actually going to need to receive and implement, it wasn't there in any of them. And so there are some bits and pieces that we're having trouble finding.
so the comment is there's some bits and pieces potentially missing from the SPDM for storage.
Mixing out to other things and you expect them to be there that are not actually in your order, but you provide no pointers to them. And so when we look at these things, and I looked at the messages, and it's just storage, is all I'm interested in, right?
Right.
And I believe you have one that was just updated last May, that's going to be production shortly, I think. In looking at what would I, as a device vendor, have to implement? When I look at SPDM 2, whatever it was, the SPDM
Sure. So the links inside need to be updated? Is that what you're saying?
inside don't actually reference what storage is looking at.
Okay. Let's take that one offline. Let's let Brett go through his session, but,
Some updates that need to be done.
okay.
That was our number one issue, and
That-
we sit in committee and we look at these things, and there's a couple other committee members in here that try to figure it out.
Sure. Yeah, they're valid when we publish them, and we can't stop other people from moving their URIs. We, as DMTF, we keep them persistent through all time. So ours are at least persistent. And I thought if you were a pass submitter into ANSI and ISO, you had to ensure that you were keeping any document you published at that URI forever. So if somebody's not doing that, you don't have to do that.
Path submitter and ANSI.
Maybe that was insights.
But the DMTF side, I mean, the spec is out there, but yeah, it's kind of vague in a lot of areas.
All right.
I ask you to look at other links to go find it from the DMTF site. But the final set of messages, I think, was on the TCG somewhere or something. Anyway, it was really over there.
Okay. Well, let's talk after, because I'm certainly willing to listen and see what we can do about that. With that, Brett's here to talk about storage.
Okay. Okay, so yeah, SPDM to storage binding. So kind of high-level mission of the binding was to give a consistent interface for storage devices that want to speak SPDM. And the goal was really to make that consistent for NVMe, SAS, and SATA. Specifically, one of the big hangups was SAS and SATA devices don't have any kind of sideband. So they can't, we can't really get MCTP to them, so we needed something. And then, because we put it on a security protocol, it's available to everyone. And then the big concern that people had was if you look at a system, in a lot of modern systems, the storage devices are, 50% of the silicon or so that's in the system. So, we really wanted to pull those in and bring them under attestation. Just kind of important note at the bottom, this is a binding for SPDM. This is not a binding for MCTP. So we did not take everything MCTP can do, PLDM and all that stuff. We didn't take that and bring all of it in. We really focused on SPDM. So update since last time, the storage binding is available. It was published earlier this year. And this really focused on the core functionality, so the attestation and secured messages commands. And then it will be supporting the authorization as well when that's available. Yeah, general command flow. So how does the exchange work? This is really just kind of the high level, but it should be familiar to everyone in storage. Right? So, storage devices traditionally, especially SAS SATA, they do not start traffic on their own. So with the storage binding, we had to follow much more of a storage flow, which is there's a send side of the equation where you would send a request, you would send any data along with that request, you get a response to that. And then there's a follow-up command that, that basically says, send me your response to that. This handshake, or this binding between these two separate requests, this is one of the big things that the storage binding actually spells out and specifies to you. And then the other part that it deals with is secured messages. So SPDM, as Jeff pointed out, all the way back to the version 1.1 has had a secured message binding. So it's had a way of coming up between the initiator and the responder and negotiating an encrypted session and then managing traffic over that session. So we wanted to bring this over to storage as well. Important note, this is meant to carry management type requests. This is not meant to carry disk I/O. We're not doing any major I/O down this. It is just a handful of management requests. And to that end, the format that we used is heavily descriptor based. So it's really not meant to be highly efficient on the bus. It's meant to be flexible for management traffic. There are a number of rules on how you can mix things, and kind of one of the big ones was you can't send a SCSI reply to an NVMe request. Just things like that. This should be common sense, but they are definitely all written down, or as many of them as we could think to write down. But yeah, that's kind of the overview of the secured request. And then the goal after publishing this is really to enable people to start implementing both attestation and this part. So, the spec's only been out a few months. We definitely want feedback on it, implementation lessons, things like that. The new stuff that we're kind of introducing this year is authorization. So this was kind of the next piece of the puzzle for SPDM. So if you look at SPDM overall as a journey, we kind of went through the sequence of saying, well, we need to know who all the endpoints are. So that was the first work. And then now once we know who the endpoints are, we need secure communication with them. So that became the next step. We've dealt with a number of different binding specs, and so it's really taking all that framework and moving it out to more devices. And now we're getting into the question of, well, we know who we're talking to, but do you actually have the right to do what you're asking for? And that's where authorization comes in. So the authorization spec, yeah, kind of definition, but it's basically that. It's, do you have rights? And you really should think of this a lot like user accounts on Linux. Just, are you the account that's been granted the right to do some operation? And when we're looking at devices, the types of operations we're talking about are things like firmware update or pulling logs. Logs might have sensitive data, so you might not want anyone who comes along to pull the logs. The one that actually kicked all this off is that bottom one, which is SPDM set certificate. Because that's actually what kicked all this off, was when we started allowing writes of certificates, we said, well, how do we know you're the one who's supposed to send a certificate? And in the end, we ended up writing an entire spec to deal with that question. And a lot of you who've written specs know how that goes. We did come up with a handful of assumptions on this, and so it's just good to spell those out. Number one assumption is you have some kind of secured message. The whole, if you can't secure the communication and ideally encrypt it, the whole thing really doesn't hold up. So you have some kind of secure message. Being DMTF, we assume this is going to be SPDM secure messages. Those could be over storage, they could be over MCTP, but there will be some kind of secure message. However, it's not a requirement that you use our secure message binding. You can come up with your own if that's what meets the needs of your target. Let's see, another thing is there has to be some way of bootstrapping credentials. Anyone who's dealt with credentials knows that, oh my word, how you get that first one in there is just a massive problem. And we've come up with stickers and pins and magic handshakes and all kinds of stuff that get that first credential in there, and no one has a great answer. And unfortunately, we didn't come up with the magic bullet either. And then just definition of the policies themselves. As you'll see, what we've created is a framework for determining and managing and enforcing policies. We didn't come up with the policies themselves, at least not yet. So high level concepts, yeah, we'll have an authorization flow. So we're going to have a couple slides that we won't really go into detail on, but we do have a couple flows for how the authorization process itself works. And then a lot of the spec spends its time focusing on credential and policy management. Yeah.
So the SCSI architecture endpoint that deals with SCSI commands, and there's no connection to the if send, if receive endpoint within the SCSI device. So how do you make those two coordinate? There's no architecture to connect them. It's not part of the SCSI architecture to allow that.
Okay, so question, if I caught it right, was there's no architectural connection between basically between the SCSI endpoint, assuming really between the management endpoint and the storage endpoint, or?
Basically,
Yeah.
The if send receive endpoint and the SCSI read write endpoint.
Okay, yes, okay, yeah, so between the endpoint that deals with if send and receive, and then the one that deals with I/O.
Disjoint endpoints.
Yeah, so that is an issue. If I remember right, the storage commands themselves are being sent to the if send receive endpoint.
Read write commands are not.
No, sorry, the SPDM storage binding ones are.
Yes.
And so that is the entity that's being attested. Yeah, if we need to come up with some other way of saying that will represent the management endpoint, then yeah, we should probably start working on language for that. We are still talking about management commands, so these are not, presumably you would not authorize just reading and writing.
Right, but the SCSI endpoint is the thing that receives all those management commands. The download firmware
Yeah.
command, the receive telemetry command.
Yeah.
All go through the SCSI endpoint, not through the.
True. So, okay, so that,
Have an authorization controlling endpoint control the other endpoint, which it doesn't have a way to talk to.
Yeah, so we might have to do some additional work before authorization can be placed on SCSI.
Okay.
Yeah.
What we did in SCSI for the automation provide interface between, the host sending commands and the automation device, tape library, is we indented this thing in the middle, I think we call it the physical device or something, and this logical unit would talk to the automation, would talk to that, and the I/O controller could talk to that, and I don't know if we went so far as to define properties, but we had this other thing and they
Okay.
to that, and let.
So there's something that basically represents the physical thing.
Correct.
So there's
Okay.
still a little more work to do there.
Yeah, that's
Okay.
one problem you might try.
No, that's just very interesting.
Is that actually a new entry in SAM?
No.
The main issue is companies are starting to require SPDM for storage. And we're having trouble implementing.
Yeah, and we need to talk.
And so this is one of those pieces.
Yep. Yeah, just a couple things about the authorization threat model. So we ended up having to look at two different ways of who is the endpoint talking to in authorization, because that's really the fundamental question is who are you authorizing? And what we ended up with was essentially, in typical SPDM, you're talking to a BMC, but it doesn't necessarily have to be a BMC. But the idea was, well, you're either talking to the BMC, so it's actually the BMC itself that's authorized, or you have a user that's authorized. And what we end up having to do because of some needs from some alliance partners is we had to do both. So we actually have a mode called USAP that is user-based. So the requesting entity is a user itself. And then we have what we call SEEP, which is really more session-based. And so that operates a little bit more like the sudo command in Linux, where the BMC itself, or whoever the requester is, will elevate their privilege, and effectively anything that comes from that endpoint is elevated. This really allows you to pick the model that you need. And we've heard some people really like USAP, and some other people really need to do something more like SEEP. So it ended up being good that we put both in. There are flows in here for both. We will not have time to get to them, but they're there in the slides you can download for homework if you're having trouble sleeping later. Then just a couple things, and I know we're down to just a couple minutes here. The spec goes through a whole credential provisioning process. So there's a process of managing the credential, which is the who you are and how we know, and effectively what the key exchange will be to prove who you are. So there's a whole set of commands to manage that. And then there are policies. And think of this as a matrix, right? We know who you are, and then what are you allowed to do? So the policy is, what are you allowed to do when you can wield that credential? An important part is the spec does not actually define what the policies are. It defines how to manage them, but it doesn't define what they are. We need partners and subject matter experts to define that in their domain. So DMTF will be working on another spec that will define some DMTF related policies, but there are a lot of different domains, as well as private commands, because all of your private management commands can also fall under this, if you so choose. Next steps, we will be working on a policy document, again, scope to DMTF. And that is it, and that brings us to the call to action. There is probably the most important thing on here is the bottom link, which is our feedback portal. So we have a public feedback portal for anyone who's not a DMTF member. And you can give feedback on any standards. This can be feature requests, this can be, hey, I don't understand it. We also do have a forum, and I'll need to get the forum link on here for OCP. But we also do have a forum. It's just at spdmforum.com, and I believe it's .com. But yeah, so we have an SPDM forum as well that we will and we'll answer questions on that. So yeah, probably time for one or two. So yes.
Is there anything in SPDM that provides a facility for the host to tell the device to sanitize itself? Or do you leave that to the regular IO command?
Okay, so question was about, is there a command to tell the device to sanitize? And no, there's not. So that belongs to the IO. Yep. Okay. Maybe one more. Okay, well, that's it. And